thought I would make a video to do one more complicated example of constructing a truth table. Alright, so this statement includes three different simple statements, symbolized by P, Q, and R. So if it helps you, you may want to think of some words that would go along with that. So let's say we have P be the statement, roses are red. Q can be the statement, violets are blue. And R can be the statement, daisies are white. Okay, so to translate this into words, we need to know the words that go along with each of these connective symbols. So what we have is P, and then the OR symbol, and then Q, and then we have another OR symbol, and sometimes we'll put commas in if there's parentheses, so that will kind of separate this P or Q from the rest of the statement. And then after that second OR, I have not P or not R. So now if I wanted to say this in words, I would just go back and fill in P, Q, and R. So this would be roses are red, or violets are blue, comma, or roses are not red, or daisies are not white. So now let's talk about how to make a truth table for this one. What we need next is to remember the hierarchy of connectives. So first we would be considering, let me write this off to the side. We would do negations first, followed by ands and ors, followed by conditionals, and then followed by biconditionals. And then in front of all of that would be parentheses. So I could have listed parentheses first, except it's not really a connective, it's just showing grouping or order for the rest of the things that are officially called connectives. Alright, so let's start making the chart, or the truth table. So I would scan through the statement and see first how many variables I have, and that would tell me how many initial columns I would include. So I have P, Q, and R. So this is going to be one with 3 initial columns. And then you need to remember there's that sort of standard setup for these things. Okay, so we would start with 4 trues and 4 falses for P. And then 2 trues, 2 falses alternating for Q. And then every other one for R. And now I have covered all 8 options. Remember there were 2 options for P, true or false, 2 for Q, 2 for R. And if you multiply, that tells you how many ways there are to combine trues and falses for 3 variables like P, Q, and R. Alright, so now we need the next thing in the table. So I would go through and look for any parentheses first. So I have 2 of those. So I'll go left to right. So I have this first parentheses would be P or Q. And I have another parentheses, so I need to do that one. Now within that parentheses there are 3 different connectives. I see 2 negations, and then I see this OR symbol. So I have to decide even within the parentheses what order to go. And since there are 3 connectives, that means I'm going to have 3 different columns. So you would start all over with this hierarchy again within the parentheses. Just like if you had an order of operations problem with a problem in parentheses, you would go order of operations within the parentheses again. So for this one I would start again and I would do negations first. So I see a negation P, and negations just negate the things that are immediately after them. So it would just be the negation of P, not any of this other stuff. Then after that, I would have the negation of R. And then finally, after the negations are done, then I can go on to the OR statement. Now that OR statement connects the 2 things on either side, the not P, and then not R. So basically this whole parentheses is going to be my next column. Alright, so that takes care of the first parentheses, the second parentheses, and then I only have one thing left to do after that, and that's another OR. So that would be my final connective to deal with. So that would be my last column. I would have the two things on either side of that. So I would have P or Q, or, and then the rest of this, not P or not R. Okay. Now notice there are 5 different connectives in that statement. Now if I'm ignoring the parentheses, but I had 1, 2, 3, 4, 5, and then aside from the initial setup of P, Q, and R, I have 5 columns following that for those 5 connectives. So if you want to do that as sort of like a second check to make sure you're on the right track, count the connectives in that statement, and then that's how many columns you should have in your truth table. And now I'm ready to actually fill in the rest of this table. So I'm going to look at this P or Q column first. So I'm going to need the rules for an OR statement. So you need to go back and look at those 5 basic truth tables and find the one that connects, that talks about the connective, the disjunction, the OR statement, and look at those rules. And remember that OR statements are only false if both statements are false. So I would be looking for things like if it was false or false, that's going to be false. In all the other situations, if it was true or false, false or true, true or true, those would all be true. Because if you say something like, I ate an apple or an orange, then that's true if you had an apple or an orange or both. It's only false if you didn't have either of those two things. Okay, so I'm going to use the rules for an OR, and I'm going to look at the 2 columns that represent the things on either side of that symbol. So I need to look at P, which is this column, and I also need to look at R, which is this column. Oh, I'm sorry, not R, Q. Alright, and then I would just follow this across. So I have true or true, and that's true. True or true is true. True or false is true. True or false again. False or true, both of those are true. And then false or false, that was my one case where the false or false would be false. So that's that first column with that first connective. Moving on, we have the negation of P. So now I want to refer back to the column for P, and then I'll just write here whatever the negation is. So I'm just going to write all of the opposite truth values. So I would have 4 falses followed by 4 trues. Next I want to do the negation of R. So I'm going to go back and look at the R column and write the opposite of all of those truth values in this new column. So I would have false, true, false, true, false, true, false, true. Okay, next I have, this column was for my OR, so I've already done not P and not R. That's these 2 columns. And now I need to join those and follow the rules for an OR statement again. So I'm going to look at these 2, and I'm going to go through and pick out any that are false or false, and those will be false. Everything else will be true. So false or false is false. Here's another one. And that's it. All of the others, these all have at least one of those 2 things is true. So those statements would all be true. And then finally, I have another column, and remember that this last one was for the OR symbol in the middle here. So I already have columns for P or Q, that's this one. and I already have a column for not P or not R. That's this one. So now I'm going to look at those two columns and follow the rules for an OR statement again. So I'm going to scan through and look for any that are false or false. So first one I have true or false, that's true. Then true or true. Okay, true or false is still true. And then I have 3 in a row that are true, 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 or true, true in all 3 cases. And then I have false, true, and that's true, and false, true is true. So it turns out that this statement, this is always true. There's no situation where that one is false. So if you're interested, we didn't have time to talk about this, but statements that are always true are called, make sure I spell this right, these are called tautologies. Right, and those are just statements that are always true. If these were all false, those would be called self-contradictions. So that's one use for truth tables. Just when you write out all of the possibilities, then you can see that that in all cases, if something is false, you might not notice that if you didn't make a table or organize it in some way, but you would be able to see that in this case. Okay, so that's an example of a more complicated compound statement and how you would go through making the truth table. So to summarize, what we needed to do was think about the hierarchy of connectives, and that helped us decide what columns to make and in what order. And then you also needed to know the rules for the 5 basic connectives. So here we only used OR statements and negations, but you would also need conditionals, biconditionals, and conjunctions, depending on what your statement was.